As I said, welcome to the webinars. Before we start, let me take a few moments to introduce Bob. For those of you who don't know him, our guest speaker, Bob, has over 30 years of experience in the EX world, and is a CompEX instructor as well as an instructor of the IEC EX CompEC scheme. We're just discussing this. It's becoming it trains a lot of people, and as a member of the US UL STP committee, and through his company, IEC is running a company that does a lot of services and provide products in the IEC world. Now, before we go on, thank you, Bob, for being with us this morning. It's so late in the evening.
That's okay.
Before I let him speak about our subject, let me run a few moments about our GMI, who we are, what we do, and why we do it. GMI is a company, safety company, running an international company, designing, engineering, and manufacturing a complete range of IS, intrinsically safe and SIL certified devices, which are used in automation packages such as DCS, ESD, fire and gas, and so on, in most of the industrial sectors, from oil and gas to food and beverage. We have over 40 years of experience, and we're very proud to manufacture our product 100% in-house in our state-of-the-art facility near Milan, Italy. On the other hand, we are a global players with presence in all the continents. Next one, we are you're using a different presentation. Okay, so state-of-the-art technology is very important to us. As we said, we make safety product. Our product is small in volume and small in monetary value to the complete system. They have an interface like a slice in between your control system and the field instrumentation, but they must provide for safety of the plant and availability of the safety system. So they're very important. That is why we spend a lot of time making sure that the product are the best we can manufacture. We have full 100% testing. We are also REACH compliant. We have SC3 certification, so for fashion safety management, and so on. Let's go to the next slide, Bob, which is the product we manufacture. So we have IS barriers, safety relays with and without line monitoring, especially for application in fire and gas. You do need line monitoring. Isolator, SIL certified isolator, power supply, EX and SIL certified. We have a line of multiplexer, temperature digital, heart multiplexer, and SPDs, indicators, and we also run a division that does training and services in the functional safety, EX, and today also cybersecurity domain. Here's the slide I was looking for earlier. It got misplaced. So we are present around the world, and we have many offices. In fact, we have 2 new offices just been put in place. One is in Mexico City and one is in Moscow. We have many distributors, and we do run a lot of courses and installation all over the globe. Next. And some of our customers, all the system vendors, from ABB to Yokogawa. We've done a lot of projects with DPCs around the globe. Let me brag a little bit here, Bob. We just won a project in Mexico City with Schneider Electric, and it's Dos Bocas with Icafluor. Very interesting project. It's the biggest refinery in Mexico. On the other hand, we have a lot of OEM that buy our product and insert and implement into their packages, from gas compressor, relay rigs, wellhead panels, and so on. And we are on the AVL of many global oil and gas companies. I believe next is you. Okay, now I remember correctly. So, Bob, thank you again for being with us. Before you start, let me mention to our guests that we will have a question and answer session at the end of the webinar. We have prepared some answer to questions you have already asked for. You have a possibility to talk to us through the question and answer box, which you've seen somewhere there. You can click on there and pose a question. We will try to answer it at the end of the webinar or throughout the webinar, depending on the question. Okay, Bob, it's all yours. If I disappear, I'm here looking at the questions.
Okay, well, thank you, Paulo. I appreciate it. And yeah, we did this presentation. I think the last time we did it was in March of this year, and I apologize because I think we changed the layouts of all this and in the summertime. So that was my fault. I apologize.
Yeah, no problem, no problem.
So yeah, we're going to talk a little bit today about some of the relevant EX standards. We talk about them a lot, and we could talk about these standards for hours upon hours upon hours, and obviously we don't have time to do that. So I really just wanted this webinar because we always get questions when we're doing competency training, for example, either under COMPEX or under the IEC EX COPC scheme. The relevant standards that we really focus our attention on are those standards that have to do with the installation, selection, and design of EX systems, as well as inspections and maintenance. So those are really the 14 and the 17 standards. But there's a bunch of different IEC standards out there, and they all have, they focus in certain areas, and there's been some new additions and some changes and some new technical specifications that have come out. And there's also some updates to some of the standards that I wanted to kind of highlight and emphasize a little bit because they may affect you. Realizing that the group that's attending here is made up of individuals maybe from end users. So you're going to be looking at one set of 600 or 80079 standards, or you could be an integrator. So you're going to be looking potentially at different standards. You might be a manufacturer. You're going to be looking at different versions. So we'll try to break it down to kind of really focus your attention or our attention on those standards that are really relevant to what you're trying to accomplish. So first off, these standards, these IEC standards, and by the way, we had a question actually that was posed, and it was a really good question. I don't have an answer for it, but somebody had asked a question about why do we have a 60079 standard, and now we've introduced these 80079 standards. And I don't really truly know the answer to that. I suspect, however, is that the 80079 standards, which are fairly new, are actually a joint ISO IEC standard, where the legacy 60079 standards were actually started off many, many years ago as just 79. And then the IEC many years ago decided to go to a 5-digit nomenclature. And then they used 5 numbers and started all the electrotechnical standards with a 6. So the old legacy 79 standards basically were updated to the 60079 standards. So there's 2 sets of standards, if you will. We have the original IEC 60079 standards, and now we also have a joint ISO IEC 80079 standards. And they cover different topics, and we'll cover that here shortly. But these standards are more or less developed by this group, TC31 within the IEC, and there's subgroups within TC31. But this is the group that's more or less responsible for making up and maintaining and where new variations or even new standards get developed within the 60079 standards. And again, these are all the HAZLOC standards. These are all the hazardous location equipment, systems, designs. They all are pretty much generated within this set of this subcommittee. Now, there is HAZLOC in other IEC standards that you will find out there. And a lot of that information we'll talk about a little bit at the end, because you'll see some of these relevant 60079 standards show up in other IEC standards. They're usually referenced as something to follow. So they take a lot of the information that might be out of these particular standards, and then they'll incorporate them into other standards. For example, for those of you who are interested in functional safety in the 61511 and the 61508 standards, there's actually reference to some of the 60079 standards. And you can go certainly to the IEC website and check out information. You unfortunately can't actually access the standards, you can go to the IEC web store and you can access all these standards. And of course, they do charge you for them, but they are available. So the standards for EX, we have a couple pages here, and I'll just briefly go through these. And many of you may be familiar with quite a few of these, but again, the ones that really, from a competency standpoint, because that's something that we get involved in quite a bit, the ones that we really focus our attention is on the 14 and the 17, and also the area classification standards. And if we were in repairing of EX equipment, these would be the standards that we'd really focus our attention on. So those are the ones that, from a user standpoint, that's typically where we're really going to focus our attention on. Some of these other standards are more specific to the development of a particular product. So using as an example, the 60079-1, that's basically telling us all of the requirements that are needed to build, in effect, a flame-proof piece of equipment, using flame-proof as the means of protection. So it will give you all kinds of relevant information as far as what are the tests that the equipment needs to undergo. It'll give you ideas or information about things like the maximum experimental safe gap. It'll provide you a lot of details as far as the actual construction of the product. Now, if you're a user and you're not manufacturing something, you're going to be basically looking for a product that would be certified, assuming it was a flame-proof piece of equipment, such as a motor or a panel. That product will be certified to that standard. The other thing that you will see also, and it's an important standard to understand, is the -0 standard. This is our general requirements. So when you go through the -0, you'll find information on all the protection concepts, but you'll find things in there such as marking of EX equipment or some of the relevant things that are universal to all of the EX standards. So the -0 is a great standard to kind of immerse yourself in. It will give you a lot of good information, what's in the other standards. So as we progress, we go 1, 2, 5, 6, 7. Those again are all product specific standards. So again, unless you're a manufacturer, it's not something necessarily that you need to delve into deeply. Certainly 11 is the same for intrinsic safety. So GMI, manufacturing an intrinsically safe barrier, they're going to be building their products to the -0 and the -11 standard. Now, also, one of the other things about intrinsically safe barriers that you'll find, many barriers can actually be installed in a hazardous location and actually have what is called type N protection, or it's actually changed now, but so you'll see the marking or you'll see the actual certificate for, say, a GMI product will reference everything from the -0, the -11, and actually -15 as well, because that's basically the construction of something that can be installed into a Zone 2 area. So as we continue to go through, and there's some other ones that I left out of this one. For example, there's a 13 standard that deals with ventilation and pressurization of buildings. So if you got into building of analyzer shelters or something like that, that would be certainly actually really relevant. And I think there's another standard, 16. Actually, 16 is not correct. It actually should be 13. So that was a mistake on my part. And again, on the last one on this page, -19, that has to deal with specifically of repair and overall.
Okay, Bob, you're back.
Oh,
I thought I lost you for a second there. Or maybe it was, not sure.
I apologize. But so the repair and overall has to deal with obviously taking pieces of EX equipment and repairing it and putting it back into service. Some of the other standards that you will see that are referenced, again, when we get into things like optical radiation or specific products like gas detectors, we'll find specific standards there. Now we'll start seeing things like what are called IEC TSs. And what TSs are basically technical specifications. So the IEC will actually publish standards, and they are just known as IEC. But they will also publish what are called technical specifications, And then they can also have other ones as well. And they're called, actually, I think they're called not TRs. Oh, I can't remember what it is, but I think it's a technical report, if I'm not mistaken. But technical
Yeah.
specifications, yeah, technical specifications are standards that are somewhat in a very early stage. They may not have approval by the entire IEC, but they are documents that either can provide guidance to another IEC standard, or in some cases might be a precursor to a full IEC standard later on down the road. So you'll see some of these when they get introduced. Sometimes they'll get introduced as an IEC TS. And generally, it's up to the subcommittee to make that determination of whether or not, if it's an important enough topic or issue, that they might want to bring this out before it actually goes to a full vote under the IEC. So you'll see a couple of those. There's process sealing, again, guidance on electrostatic hazards, control of potential ignition sources. A new one that's actually created quite a bit of, I don't want to say headache or heartache, but it's kind of filled a niche, if you will, is what is called this IEC 46, TS 46. And what this has to deal with is specifically assemblies of various components that are EX certified as individual products, but then we're bringing them all together and building, say, a skid package or something like that. So this technical specification is providing guidance, if you will, on the requirements for building a skid package. And in effect, if you think about it, it's basically saying, in effect, we need to bring products that are EX certified, and then we have to install it and maintain it, or not so much maintain, but we have to do an installation to the -14 standard, that all the interconnects between all the equipment that locates or as part of this equipment assembly is all going to be part of that. Now you'll
So
see.
Bob, sorry, Bob, interrupt you. I was wondering, so what is a technical specification? Has the same relevance of a standard? I mean, you have to apply, by law in the same way, or is just recommendations?
So this is always a question. These IEC standards are just that. They're standards. They're not, they have no regulatory, they're not mandatory. It's up to every country to determine whether or not they're going to adopt them in their regulatory framework. So in some cases you have actually, and I've seen this now actually with this TS, there are some countries in the world that have actually stated and put this TS 60079-46 as part of their regulatory framework. So it might be either a country, or it might be an organization like, say, for example, the US Coast Guard, or it might be another organization somewhere in the world that's overseeing EX installations in some way, shape, or form. If they adopt that and they put that in the regulations, then yes.
And it becomes a normative.
It becomes a standard or a regulatory issue. So,
okay.
Yeah, and so now we're starting to see some of these 80079 standards. And actually, if you notice these first two, the 20-1 and 20-2, for those of you really familiar with the IEC standards, there used to be a 60079-20-1 and 20-2. Those have been basically replaced now by these 80079 standards. And what those standards are basically giving us the characteristics of various gases and vapors of all of their flammable ratings, if you will. So for example, you want to know all of the relevant information about, say, acetylene or hydrogen or cyclopropane or methane. All of that information will be listed within the 79-20-1. That's where we'll find out our T codes, what gas groups they are, and all that good stuff. Now, there's a fairly new one that's come out, or I should say it's really been updated, the -34 standard. And this, there was an edition 2 that came out about 2 years or so ago. And what that standard is that is more or less a bolt-on to your ISO 9001. So if you're a manufacturer of EX equipment, that standard is for you, if you will. And it goes in, and it's more or less, it takes the relevant information for you under your quality process, and extends it out into manufacturers specifically around the production of EX equipment. So I'm sure, Paulo, that you as GMI, you probably have to comply with the -34 standard now.
Standard, yes.
Yeah, that's a
you actually get a certificate. I'm not sure what it's called now, but there's a company certificate that EX certificate is not for product, but it's for the manufacturer itself.
Right.
There's a special name for that.
Yeah, it's very similar to your 9001 ISO certification. So in many cases, it could be that same organization that's auditing you. They'll audit you around that as well.
Yeah, and it differentiate from different, for example, IS or EXD, or you have to apply for. You might have multiple type of manufacturing, so you have to apply for the different solution. Right. When we started selling some EXD, SPD, we had to reapply, get a new certificate for that because we only had IS in the past.
Right. Now the 36 and 37, I'll talk about here in just a little bit later, but those are fairly new, and those have to deal specifically with non-electrical equipment for use in hazardous locations. And this is creating quite of an issue with mechanical people, because now we're having to take a look at things like bearings or pumps or various mechanical equipment that potentially could be an ignition source. And there's a couple other ones. The personal competency is a technical specification. It has not yet been published. It was supposed to come out this year, but from what I understand, it's actually going to be published early 2022. And then there's also a 45, which deals specifically with internal combustion engines, which again has not been published. And if I go to my next slide here, let's see. Oops, let me clear this. This. So the question always comes up about the Euro norms, because I understand. I mean, this is an international webcast, right? I'm sure some of you are probably located in Europe, and there's a relationship between CENELEC, who is the organization that writes European standards, and the IEC. And so what happened many, many years ago, I shouldn't say many, many years ago, but there was an agreement. It was called the Dresden Agreement between the IEC and CENELEC. And they basically came and they said, hey, the CENELEC was up until that point responsible for writing all of the European standards, the EN standards. And of course, the IEC was developing IEC standards. Well, there was a lot of overlap between CENELEC and the IEC. So they basically came to an agreement and said, look, when it comes to these particular standards, one of these two organizations will take the lead. And with regards to HAZLOC standards, it was determined that the IEC should take the lead. So what happened at that point was CENELEC basically got rid of the old 5000 series CENELEC EN standards and adopted, in effect, the IEC standards and called them an EN standard. So what you see here in this picture, you'll see an example of an IEC standard 60079-1, edition 7 from 2014. Then on your right-hand side, you'll see what is called a BS EN 60079-1 from 2014. The base of the standard is identical. As you actually look through it, you will see that the actual technical requirements for the product, regardless if you build it to an IEC standard or an EN standard, it's identical. But there are some differences between the two standards that we have to pay attention to, which we'll talk about here just in a little bit. So, and it's going to be very interesting to see what happens now with the UK pulling out of the European Union. They may just go to a BS IEC standard, or they may continue on with the BS EN. And we've seen some standards that have been published as a BS EN IEC standard. So there may be some different variations on it. But basically, if you see the 60079, it started off as an IEC standard. So what is the difference? Again, Euronorm standards are published and developed by CENELEC in Europe. And again, they're known as Euronorms. And again, most of the IEC standards have been adopted as a European standard. And that's true for not just the HAZLOC standards, but almost all of the relevant IEC or 60,000 series. So many, many, many different IEC standards have now been adopted by Senelec and have been published as the EN version and then adopted within the various countries within Europe. So the IEC standards are referenced, harmonized as EN standards. So for example, in Annex ZA, if you look at a BS-EN or an Italian version or a German version or a French version of the EN standard, in Annex ZA, any of the IEC standards in the front will be referenced as an EN standard. And again, the main text of the technical standard is identical. So the important thing to note, and there's different certification schemes in the world. You have IEC EX, you have ATEX, you have other certification schemes that many of you are probably familiar with. As long as the original base standard, for the most part, starts off as an IEC standard, for the most part, all of these country-specific 60079 standards, the technical aspects of the standard are pretty much the same. Usually what that means is that there may be some variations to it. For example, if you wanted to take products and use them in Brazil, they'll require you to follow the ABNT 60079 set of standards. So what's the difference between an ABNT and an IEC 60079 standard? Well, the technical aspects of the standard is the same. However, they'll have some specific country requirements, such as marking in Portuguese. And one of the other things is that you actually have to have it certified by a Brazilian test lab. The Russian standards are very much based upon the IEC standards. You will see this in Australia, where the ASNZS are based upon the IEC standards. So even in the United States, we have now ANSI UL 60079 standards. And we have adopted those here in the United States for the zone concept. And in many cases, the product standards are virtually the same. Here in the United States, we do require some additional text or an IEC EX product in the United States without some additional testing.
Yeah, it's a lot of different certification scheme. That's what it is, Bob. We have a question for you guys, making sure you have understood. It's a simple question, but maybe you don't get misled. So which standard, 60079 standard, applies to every EX certified electrical product? You know, we remember there's many 6079 -1, 7, 11, 24, 48, 45, 0, and so on. Only one applies to all. And it's intuitive, but you know, anyhow, coming back to the standard, Bob, you know, we have the ATEX standards, which the EN standards, which become an ATEX certification scheme, which is identical to I.
Oh, I think my internet is messing up. I don't know if you guys can hear me or not. But Paulo, you've locked up.
CX, but which is out of the EU, you have to recertify. We just recertified all our product to the relevant standard in the UK, which are again, you know, the same as the EN standard. But okay, guys, we give you some time to answer this question. Simple question. I have to say, not everyone has been listening. I can see the result live. I haven't shown this with you yet. If I understood the question correctly, Bob, let me end the poll. The correct answer was A, right, Bob?
That is correct. Yeah.
Okay. Well, this is the result you guys give. 63%. So majority of you answer correctly. Some have not, but only the zeros. This -0 is like the overall standard, right? What was the title? I forgot.
Right. Yeah. So, I mean, like I said, what you're going to find in the -0 standard, if you will, is going to be marking for EX products. Some of the other relevant requirements for every piece of EX equipment that you build. So the -0 is kind of the Bible, if you will. That is our general requirements, if you will, that apply to no matter what protection concept you're using. So the -1 happens to be flame proof, -7 is increased safety. -11 is intrinsic safety. So when you look at a certificate, and we'll look at one here in just a second, either an ATEX EN type examination certificate or an IEC EX certificate, they'll reference on a product, it'll always reference the -0 standard, and then it may reference one or more different product specific standards depending on the protection types used with that particular product. So, all right, I'm going to close that little thing and we'll continue on. So markings for products, and we've done some webinars on markings, but this will just kind of maybe be a little bit of a review. On the top line, what you see, that's the marking requirements under the ATEX directive. So you have to have a CE mark. The 0722 is the organization, the notified body that actually holds the certificate, if you will, or potentially was the ones who issued the certificate. The hexagon EX, you have Roman numeral 2, which is surface industry. Then you have category 2, gas and dust. So the back part of the marking string, everything that you see from EX, DB, 2B, H2, T5, GB, that marking is identical to the IEC requirements, or under IEC EX, if you will. So what you see on the label of this product, you see a certificate that's an ATEX certificate at the top, and then you'll see an IEC EX certificate at the bottom. And the markings are basically identical. It's just an example of somebody marking it in such a way to where they have a product that's certified both to the ATEX directive as well as IEC EX certified. Okay. Now there has been some significant changes, and this might apply to people that are doing installations. And there was a big change with regards to the installation standard with regards to cable gland selections. And this all had to do with barrier glands. And without going in too much detail, the latest edition of the -14 standard basically changed the cable gland selection criteria. And within the UK, they did not agree. And so on the right-hand side, you'll see that's what is called a national annex. And that only exists in the BSEN 60079-14 standard. And this is basically saying, in effect, in the UK, we want you, if the selection of cable glands, we want you to follow the requirements of the older standard. So this is an example where countries can take exception, and they will actually write something in and actually put a national annex. But this is very unusual, but this was a very contentious issue that took place. And basically, this is a chart that shows why this was important. On the left-hand side, this was the old way that you would select either a barrier or a non-barrier cable gland. So in this case, if it was going into a zone 2, 2B environment, we had a flame-proof box and we had a flame-proof motor. There was no requirement to use a barrier gland. On the right-hand side, in the latest edition, depending on the length of the cable now, that's actually the determining factor of whether or not we had to use a barrier gland. So if you actually look at something on here, and this has created a lot of confusion with inspectors and people in industry, but if you look at this flame-proof box right here, this is an example of a barrier gland. This is an example of a non-barrier gland. And that is something that people, if you didn't know this, you might be very confused. You would think, well, wait a minute, you've made a mistake because you've used a barrier gland and you didn't use a barrier gland here, or vice versa. But this is actually based upon the length of cable requirement. So it's important to understand, again, some of the differences. And if the country has a specific national annex, it's always important to understand that. And I'll pass by this because that's actually, let me go back to this one. It is an important thing to remember is the latest standard, the 2013 standard, and I'll just highlight this because the next question will basically be this. The requirement is that if the cable length is 3 meters or less, between an EXD box and a non-EXD box, then it requires a barrier gland. If it's 3 meters or longer, then it does not require a barrier gland. So again, if we look at the chart over here on the left-hand side, what you're seeing, this is the older standard. We didn't care about the length of cable. It was more based upon gas groups and everything else. This one, if the cable is 5 meters in length, we do not require barrier glands. And again, if this cable is 5 meters in length, we do not require barrier glands. So going to our next poll question.
Well, that basically now you gave the answer, already to this question. Just a second ago, if anyone gets it wrong, I'll be surprised. So what is this length of cable? Referring the standard, it should be less than 5 meters, more than 3 meters, and so on. Bob, let me ask you a question. Why? What's the difference?
Yeah.
What's a 5 meter cable do instead of a 2 meter cable? What's the difference?
So the purpose of a barrier gland is to keep, well, it's to do a couple things. Number one, it's to keep the explosion from exploding the cable out, number one, right? Because if you have an explosion on the inside of a flame-proof box, the explosion is going to go to the path of least resistance. So the packing, the barrier, if you will, stops that explosion from traveling down the cable.
Okay.
Now, the reason why they've made this change, or if you will, why is it if we can now use a longer piece of cable, it's because the cable construction, and there's a caveat with this, which I didn't say, but if the cable is an extruded bedded cable, it's solid bedding, meaning that there's no cable fillers or no fiber fillers or anything like that, which a lot of industrial cables, either steel wired armor or marine jacketed type cables, will have what is called an extruded bedding. And it's basically a solid mass, if you will. There's no fiber fillers, there's no paper fillers. So the thought process is that if you have an explosion hit that cable, there's no place for that explosion to go. And gas will not, if you have the length of the cable longer than 3 meters, then that gas will, there will not be enough to transmit between the flame-proof enclosure into another enclosure. So it would have to travel a long distance before it actually got out. So it's actually doing.
So basically the correct answer was less than 3 meters. So when the cable is short, there is more of a chance of it to blow out because there's no way for the gas to go. It's like a plug.
That in effect, yes. Yes.
That's what I understood.
Yeah, no, and that's it. And actually, ironically enough, I just found out, I have a friend of mine who's on that committee, that TC31 committee, and they are changing the cable gland selection criteria again in the edition that will be published in 2023, and it will be different than this. So it's going to change again. It's not going to go back to the old method. It's not going to be this method. It's going to be a different method altogether. So
I guess it's, it's not easy to make such decisions, based on occurrences which are difficult to control. There's so many variants.
Yeah. And so that's why, and to be honest, these standards change usually every 3 to 5 to 7 years or so. And that's why the competency programs that we teach. So many
different type of cable, not easy. I'm not sure.
Yeah, the certification only lasts for about 5 years. And so that's why.
Okay. I'm not sure about whether it's you, me, I don't see you anymore, or everybody's not seeing you anymore. All of a sudden, things froze up.
Yeah, I don't know. Maybe it's early morning in Houston. We're just nothing.
Or maybe it's my connection and everybody else is fine. I'm not sure. Let's hope so. Okay, let's go on. We are running late, I think.
We'll get there.
I don't remember how many slides there are, but we are into 45 minutes almost.
Yeah, we'll finish up in 15 minutes here. So a lot of questions people ask, how long are these standards valid? And this is really important to understand from a manufacturer's perspective. So the IEC EX actually publishes a document And it basically says, if I want to test a product, I must do it to the most current standard or one edition prior. So that's something that's very important. Within the European community, they do the same thing. It's a very similar process where they basically say a particular EN standard will come into effect, and then when a newer edition comes out, then the older one will eventually be withdrawn, if you will. So it's important to understand, especially if I'm building products and I'm incorporating products where maybe from a certification standpoint, one of the things the certification bodies are always going to look for is products that are certified to the latest standard. So this is just an example of for example, a GMI certificate, an IEC EX certificate. So what I mentioned a little bit before about what standards will be actually referenced. So in this case, you find the -0, that's the general standard. There's the requirement or the standard for intrinsic safety. There's the standard for type N protection. And actually this standard E protection, increased safety, a lot of the N type protections are now falling into the increased safety standard. There's been some changes. So this standard -15, a lot of this is going away, and it's going to wind up in some of these other standards. So this is our marking, what you would see on the product, and these are the relevant standards that we need to follow, or what the manufacturer has actually built the equipment to. Looking at a type examination certificate, again for GMI, what standards? Now in this case, because it's a European directive, compliance to the ATEX directive, we're actually following the Euro norm standards, which are published by Senelec. And so we're referencing the EN standards. Now, in some cases, these were joint EN IEC standards that were published at the same time, but some of them were actually just IEC standards that became EN standards at a later date. So that's why you see the requirements or the markings on their certificates, and you can easily find out if they built it to the latest standard or a previous one or whatever it is. So the standard format, and this is true for all of these standards, there's a scope, terms and definitions, the main portion of the standard, there's things on IP ratings, then there's annexes, there's what is called normative, they provide additional normative text to the main body, and then the informative. And this provides a little bit more understanding of various parts of the standard. So sometimes people look at the standard and they don't really understand what it means. If you look in the annexes, sometimes under the informative information, it will actually explain, excuse me, it'll explain it in somewhat a more easier to understand. So sometimes the information is right there within the standard, but when you read it, it's very difficult to understand. Go to the back of the standard and you might find some informative information that will help you understand what they're trying to say. And again, the standard format in the Euro norms, it's basically the same with the exception of our annexes. And this is where we reference the relevant IEC to EN standard. And then there's some additional things with regards to marking to be in compliant with the ATEX directive. And that's telling us that we have to put a hexagon and our CE and category information and all that good stuff. So I'm going to zip through this because we are kind of running a little bit out of time. So there are some 80079 standards. It's the 80079-36 and 37 standards. So really all I'm just going to say about it is that they were developed originally by Senelec as EN standards, the 13463 set of standards. And then basically the IEC and ISO got involved with this, and they said, hey, we like this, we want to introduce these as a 80079 standard. And this, again, it does not apply to electrical equipment, but it applies to mechanical equipment for use in hazardous locations. So these are the latest set of standards. So when we're talking about non-electrical equipment, And really, these faults or these potential sources of ignition apply really to electrical as well. But this is what these standards are really talking about. If we have any mechanical equipment that potentially could generate any of these potential situations, then we want to take that into consideration, and we want to look at that and make an evaluation on that particular product. So again, where this is coming from is that we're finding out that in many cases, a lot of these industrial accidents that were caused and explosions within facilities were actually not necessarily electrical issues, but they were mechanical equipment. It could have been bearings, it could have been valves, it could have been something else. So that's where these standards have come from, and you're going to start seeing more and more of this. So there is an IEC EX certificate for it, and here's an example where you'll see there's a reference to an 80079-36 and 37. Again, it doesn't reference the 60079 standards because it's non-electrical. And then the marking, and I don't know if you can see this very well, but I'll see if I can highlight this. You'll see there's something down there called EXH, and that's what is considered to be the protection concept. They use that designation for all mechanical equipment called EXH. There are some other changes with regards to some of the marking requirements. Again, I'm not going to go through all of this, but I just want to highlight, for example, many of you may be familiar with the old technology or old terminology of EXD. Anything that was legacy EXD and is now being produced by manufacturers will be coming out with what is called a DB. Same thing holds true for EXE. They're coming out with new markings. So an additional letter has been added to the protection concept, and that's what we call an EPL. And that is telling us in effect what zone that product can be used for. And clear that. Hold on, apologize. Clear that drawing. And we'll move on to the next one. So some of the other standards I mentioned within the IEC world that you'll see references to hazardous locations, the 61892, that deals specifically in the offshore business. The 60034, rotating electric machines, you'll see obviously motors for use in hazardous locations. What you're hearing about now with LNG fueled ships, they reference the IEC 60092-502. And that, again, also references some of the 60079 standards. And then, of course, you'll see other country-specific standards that will reference IEC standards, right? And again, as I mentioned earlier, many countries will base their standards upon the IEC standards, but they may require additional testing and or certification. Generally, it's not testing, it's usually more certification, which means basically just paying more money, in a nutshell.
Okay, well, we have another poll here. You okay, Bob?
Yeah, I am.
You're talking too much. So, regarding mechanical equipment, what is the most likely source of ignition for those equipment when using ASLOC? Keep in mind, there's a multiple choice. You can answer more than one question. I guess the most likely would be one, but you know, it's difficult to determine.
Yeah.
So we have electrical spark, hot surfaces, static, electricity, or mechanical generated spark, or exothermic reaction.
Yeah.
And exothermic reaction sounds a little, I'm not sure.
Yeah, so exothermic reaction is where you might have a hay bale or straw being stored, and you'll actually start seeing that during that heating up process, you'll actually, yeah, is that exothermic? Yeah, I'm trying to.
No,
right now. It's early in the morning. My brain is not completely there. But
if I was to throw one, you know, the most likely I would think, you know, would be hot surfaces, but
it is. It's hot surfaces or mechanically generated sparks are typically the two most common sources of ignition for mechanical equipment for use in hazardous areas. So again, a hot surface could be something that overheats, could be obviously whatever it is mechanically. But if a bearing sticks or something like that or fails, you could have that mechanically generated spark, or you could have it heat up. And that's typically where we're really finding a lot of problems. So
yeah, that's why we have the T class, no? So that we can control the temperature class.
right, we do that with the electrical equipment, and now we're doing that with mechanical equipment as well.
Okay, these are the result. So there were no wrong answer, correctly.
Right, right. I guess you could say electrical sparks really wouldn't be a right answer, but you know.
Yeah. Okay, next.
Yeah, so again, standards are important, but they're not the whole story. And again, regulators' acceptance of the standard is just as important, if not more so, because, and again, it could be a regulator, it could be a major company that says, hey, we want to do this, we want to incorporate these standards into our standards. So it's really important if I'm an OEM, or if I'm a supplier to a major oil and gas company or a pharmaceutical company, I want to pay particular attention to their standards and what they're requiring, because it always is obviously very, very important that we want to make sure that we're providing equipment that's right. And if I'm a major oil company, if I'm a major pharmaceutical company, and I'm responsible for what's going into my facility, I want to be very aware of what are the latest standards, what are some of the latest things that are being developed. Do I actually want to incorporate them into my corporate standards? And certainly the regulators themselves, they need to be aware of this and determine whether or not they want to incorporate that into their specific requirements. But again, don't assume anything in EX. Always look at the standards, ask questions, try to find out the information, because again, we're only as strong as our weakest link. So,
all right. Great, Bob. So we have a few moments for question and answer. Well, you guys, as I said, you can, ask questions through the question and answer box, but we have prepared some answer to some questions which were posed earlier. Let me see if I can find the right slide to share with you. Okay. Do you see that, Bob? I don't see it myself, but do you see it?
I see it.
Okay, so this was the first question, right? Do you see the first question? What would be some typical example of a mechanical EX equipment?
Yep, I see it.
Okay, great. So everybody sees it.
Oh, I see it.
I'm working on two screens and sometimes it gets a little funky. Okay, so what is the answer to this one, Bob?
Well, you have to advance it.
Yeah, I think I went too far. No,
that's it.
Oh, that's the right answer. Yes, sorry.
Yeah.
Okay.
So we talked about this, a bearing overheating, or it could be something of normal functioning of the machine, but a hot brake surface is a good example. That label that you actually see there, that's from a fan manufacturer that has actually gotten their fans, the non-electrical portion of the fan, actually certified for use in hazardous areas. Now, you would think a fan in and of itself, well, what is the ignition source or potential ignition source from a fan? Well, it may be the material that the fan is made out of. Is it sparking? Could it build up an electrostatic charge? Or if it fails in some way, shape, or form, but while it's spinning or operating, if it fails in a manner in which it potentially could create an ignition source. So this manufacturer has gone to the trouble of going ahead and doing an evaluation and getting their certification on it. So these are the types of products that you're actually going to start seeing that are certified now to these new mechanical standards.
Okay, we have another question about Russian standard. What are the equivalent Russian norm to the IEC standard? This is the slide we prepared. The GHOST standard, or TC.
Yeah, and actually they've changed some of these numbers just here. Not too terribly recently, but not too terribly long ago. But yeah, they are the GHOST standards. They are based upon the IEC standards. And what you see in this picture way down there below, you'll actually see a marking on an EX box, and you'll see that their marking requirements are slightly different. And of course, the language must be in Russian, but the actual technical requirement for the product itself is based upon, in that case, that's a picture of a flame-proof enclosure. That's a product that's already IEC, EX, and ATEX certified and is certified under the 60079-1 standard. And so to meet the requirements in Russia, they didn't have to do any additional testing from the flame-proof portion of the product. It was more of a marking requirement and operation manual requirement and all that good stuff.
And they do have inspection also, because we certified to the IEC standard, Russian new standards, and sometimes it depends. Now with the COVID situation, sometimes they do online inspection, but
right.
It's part of, and also another requirement you have to certify to Russian standards is that you have to have a local person, somebody based in Russia, which is a guarantor for the certificate. They will not issue a certificate unless you have a name there. It says this person is responsible for this product, this certificate. So that is one of the reasons why we opened a GMI Russia, to have ourselves in Russia as a legal entity, be able to certify it. Otherwise, you cannot certify the product.
Right.
Of course, you can have, the other people, so you don't have to, but it's easier if it's yourself, Yeah. Okay, next, a question about what about other parts of the world under similar standards, the IEC? I think you did mention that earlier, but here we go.
Yeah, we did. But yeah, these are some of the other standards that you'll find around the world. So we, again, in the United States, we've adopted the 60079 standards, and I'm on that committee. And we've just now adopted all the mechanical standards as well. So Canada has adopted the IEC standards, the Brazilian, they've adopted them, Australia, New Zealand, and many other countries around the world. So in some cases, and even Europe, if you think about it, ATEX is adopting the IEC standard, except you have to do some specific markings and you have to go through a notified body and all that good stuff. But they're all based upon the IEC standard. So what I tell people is that, look, if you want to take your product or you want to do work around the world, if you study the IEC 60079 standards, everybody has just got a flavor on it. It's we're all doing variations of it. Unfortunately, we're not in a situation where we just accept IEC EX worldwide. That was the goal. There seems to be always like somebody's going to put up some sort of trade barrier in some way, shape, or form, including the United States. We've done that. But anyway, yeah, most likely,
it's like that.
Yeah, it's just like that. It's you pay your fees and get your certification. And
there are, as you mentioned, differences. For example, I remember Japan is another country that adopted the IEC standard, but they interpret it the way they like it. And sometimes means that what you have done is not 100%. The marking, for example, for a barrier, we have to submit safety parameters. How much inductance and capacitor we can handle through that barriers, and you can see differences in how different countries. So then you end up with the different marking, or in our case, typically, if it makes sense, we select the safest of all, and we mark with that. Whatever country determine the lowest number, okay, we put that lower number. Because otherwise we have to. It's impossible to mark 10 different parameters on the box this size. But yeah, there are some differences, but at the end they're all the same, and you have to end up paying for it, but anyhow. All right, so again, there are no open questions, but we have a lot of questions all the time about webinars. Can we do another webinars? What can we view with? So we have a live webinar schedule online. We can also run on-demand webinars. You can go on our website and look at it. You can request for your own webinar, of course, for your company webinar. We need, some people there, and all the webinars are recorded to my, I don't know how to say it, my dismissal. All the errors I make are recorded there. You can see them on the YouTube channel, GMI YouTube channel. If there are no open questions, I'll launch the final poll, which is how did Bob do today? We thank you for your participation, for being with us. We hope you found this useful and interesting. Keep looking for our additional webinars on functional safety, cybersecurity, product application, safety relays, power supply on EX, on IS, and so on and so forth, and whatever we come up with, right? Well, we have to come up with some new ideas now.
Yeah, got to come up with some new ones. Yeah.
It's been quite a while, a lot of webinars we run, so we need to, maybe guys, you have ideas, you want us to talk about something, just shoot us an email, we can look into it.
Yeah, and let me give a shout out to the GMI YouTube channel. So I mean, if you have questions on, for example, on reading an EX wall chart, or if you have a question on the competency programs, the IEC EX COPC program, we've got a full webinar that we did on that. How to understand labels, the markings on EX products. We've got a webinar on that. So there's a lot of good information there if you want to just waste some time getting on YouTube and educating yourself a little bit. There's some really good information there. So I would encourage you to check it out, and hopefully you can learn something.
Okay, so thank you. I'm sure that excellent is for Bob and the good is for me. So thank you, guys. Thank you for being with us. Thank you, Bob, again. You all been very helpful, very informative. And I don't know what else to say. Go to bed.
Yeah, that's what I'm gonna do. I'm gonna go home, go to sleep, and get a couple hours of sleep. So
okay, thank you again.
Bye-bye,
guys. Bye-bye. See you next time. Bye-bye.
Ciao.
Ciao.